research intelligence platform, staying on top of academic research. As an AI/ML researcher today, you're drowning in papers. There are 200 to 275 new preprints that hit arXiv every day. You need something smarter than keyword alerts. You need to know when someone extends your work, contradicts your findings, or builds on that specific technique you're exploring. You need a system that proactively looks for such papers as soon as they're published so you can stay current with your field. Research intelligence platform is our swarm of agents that do exactly that. Let me show you how it works. You could start with ingesting your existing corpus of research papers and then telling the system what you truly care about, which is relationships and not keywords. In this case, extension of certain papers of interest, as you can see here. So these are relationship-based rules. And now let me show you the knowledge graph that powers this. And this is all happening behind the scenes with our agents working in tandem. So here we are. This is where the magic begins. And let's go back in time and start with our initial corpus of 25 papers. This, as you can see, is a sparse graph with a handful of relationships. We're showing extension, support, and contradiction as the three types of relationships that could exist. We've also ensured causality by time ordering papers by their publication date. So as time progresses, you can see that the more papers are getting added through the scheduled archive watcher job or manual upload, and the knowledge graph starts getting more and more interesting with more connections being formed. The edge density increases by about 35% as the corpus doubles in our case. As we add each paper, it is analyzed by our entity agent, which extracts metadata, authors, and key findings. After that, the relationship agent compares every pair of papers to determine what kind of edge, if any, needs to be there. And all of this is just based on pure semantic understanding, and there are no citations that are needed. So let me click on one of the papers that we are tracking, for example, this one. And you can see in this case, there are two kinds of edges that are incident on this node. The ones going out show what this paper builds on, which is prior art. And the edges that are coming in show the papers that extend this particular paper. So this is bidirectional intelligence. You can see both the foundations and the innovations built on top. So that is your entire research ecosystem in one click. Let's move on to the proactive alerts tab. So here is where the system does the work for you. You don't have to search, the system watches archive for you. A new paper comes in, the alert matching agent checks it against knowledge graph and your watch rules. When it finds a match, like in this case, the tree of thoughts paper with 92% confidence, you get an email. No searching, no missed papers, just intelligence delivered to your inbox. So what's behind the scenes? Behind this is a fully serverless system on Google Cloud Run. Why serverless? Because as a researcher, you don't want to manage the infrastructure, you just want it to work. Beyond the three agents that we referred to earlier, there are three more agents that are there that enable grounded question answering based on interactivity with the knowledge graph. Also, there are three Cloud Run resource types, four services that are shown here, three jobs, and one alert worker that sends out an email whenever there is a match. So 100% serverless, scales to zero when idle, scales up when papers flood in. Google ADK orchestrates the agents, and Cloud Run handles the infrastructure. So research intelligence agents, your proactive research assistant with Google Cloud Run and ADK. No servers, no missed papers, no FOMO. You can try out the live link here.